Okay, so as we left off in part 2 of these notes, if it has a metal and the delta N is above 0.4, it's ionic. If it's above 0.4 without a metal, then we're going to count it as a polar covalent bond. Next, we're going to get into the shape of the molecule, and that's important because it's going to tell us a lot about its behavior. So once we learn how to draw it, we can determine if the entire molecule is polar or nonpolar. From there, we can determine the types of intermolecular forces. To do that, we use what's called Vesper. That stands for valence, shell, electron, pair, repulsion. Okay, so that's just a fancy way to say that the electron pairs repel. Why do I show this to you? Because you may have questions on tests or quizzes where it mentions Vesper, and I want you to just understand that it just simply means the electrons are as far apart as possible. So these electron pairs repel. What is it about these electron pairs that causes them to repel? Okay, so why do electron pairs repel? They repel because they're all negative. And like charges repel. So opposites attract, like charges repel. And because of that, they want to be as far apart as possible. You'll have to keep this in mind too when you're drawing these molecules, that you're looking at it two-dimensionally on a piece of paper, but it's actually three-dimensional. And so those electron pairs repel themselves three-dimensionally in space. When you build these models, you'll get to see some of this. So we're just going to start with a quick overview of Lewis dot structures, just in case you need a refresher. So water, H2O. Now the valence electrons you're going to find at the top of the column. So above oxygen, you should see a Roman numeral 6 or a 16. Either way, this will tell you that you need 6 valence electrons. Because as you know, obviously, you can never have more than 8 valence electrons. Also notice I put the hydrogen on the outside. Hydrogen will always go on the outside. And hydrogen has 1 valence electron. You can use different symbols, but you don't have to. And whenever you draw your structures, you need to have an octet, which means 8 electrons around every atom except for hydrogen. Hydrogen follows the duet rule. It only needs a total of 2. And then we have 2 different types of electron pairs. We have this pair right here and this pair right here. Because they're not between atoms, we call these lone pairs. They're all alone. And then between the atoms, we have shared pairs. A shared pair is also known as a bond, And because it's only one shared pair, this is a single covalent bond. So we actually have 2 single covalent bonds here. Could we have a double covalent bond? Sure, if there are 2 pairs. So when we draw our molecule and we look at it three-dimensionally, these electron pairs are all going to push so that they're far apart as possible. What this will do, it will actually push water into this bent shape. You'll get to see this when you make your models. So in a three-dimensional space, they all push so they're as far apart as possible. And so these 2 lone pairs push water into this bent shape. Okay, because it has this bent shape, and I know that oxygen's electronegativity is 3.44, and hydrogen's electronegativity is 2.2. Within this bond, because oxygen has the higher number, oxygen pulls on the electrons more. And so we draw an arrow to show that oxygen is pulling on those electrons more. It's kind of like this is the rope in a tug of war, and oxygen has more of the rope on its side because it's pulling on those electrons more. So in both of these bonds, the oxygen's winning the tug of war, and it's pulling those electrons over to its side of the molecule. And because it does that, it has more electrons on its side than the other. And it creates what we call a partial negative charge. To represent partial, we use what's called a Latin delta, and it's kind of like an 8 that's not quite connected. That means partial. And so if the oxygen side is partial negative, the hydrogen side, because it's losing the negatives, is partial positive. And because of this, water has positive side and a negative side. So it has poles. Okay, so you're taking a test or a quiz, and you need to figure out the shape. The first thing you want to do is draw your molecule, showing all the electron pairs as far apart as possible. So if we draw methane, remember that's what I made the bubbles out of that I lit my hands on fire with. So when I lit my hands on fire, I was burning methane. Methane is CH4, and that's what you burn, obviously, when you burn something with your Bunsen burner. So that's what comes out of the Bunsen burners. Okay, carbon always goes in the middle. Hydrogen always goes around the outside. And hydrogen has 1 each. Carbon, when you look at the top of the column above it, it has a Roman numeral 4 or a 14. So it has 4 valence electrons. So we can see from our structure here that there are no lone pairs. All of the pairs are bonded pairs. There's a single bond here, a single bond here, a single bond here, and a single bond here. So this is our Lewis dot structure. Then we can also draw what's called a structural formula.